In this video, we're going to learn about Bronsted-Lowry acids and bases. A Bronsted-Lowry acid is a substance that donates protons. A Bronsted-Lowry base is a substance that accepts protons. Let's look at an example reaction. Here we have nitric acid and bicarbonate reacting together to form nitrate and carbonic acid. Notice in this reaction, nitric acid donates a proton to bicarbonate, and therefore the nitric acid becomes nitrate, while at the same time bicarbonate accepts a proton and becomes carbonic acid. In this particular reaction, nitric acid is acting as the acid, and the bicarbonate polyatomic ion is acting as a Bronsted-Lowry base. Let's look at another example reaction. Here we have aqueous ammonia reacting with water. In this reaction, the ammonia accepts a proton from water to create the ammonium cation, and the water, after donating a proton to ammonia, produces hydroxide. In this reaction, the water is acting as an acid, donating a proton to the ammonia. So the ammonia is acting as a base, accepting a proton from water. Here is a list of the 7 strong acids and 7 strong bases that you should memorize. You will also need to be able to identify other Bronsted-Lowry acids and bases based on their chemical structure and chemical formula. So here's an example: acetic acid. The chemical formula is HC2H3O2, or alternatively, sometimes it's written in this form. Notice that in this class, I'll always write the chemical formula with the acidic proton first so that you can identify acids. Here's the chemical structure for acetic acid. For acetic acid, this is the acidic proton. And when the proton is donated, it generates acetate and a proton. You also need to be able to identify organic bases. Here's one example. This compound is called pyridine. The chemical formula is C5H5N, and this is the chemical structure. Notice that there's a nitrogen with a lone pair. Remember that bases are proton acceptors. The lone pair on this nitrogen is a region of a lot of electron density that could stabilize the proton. And so the acid-base reaction would look something like this, where the pyridine electrons interact with the proton and generate this pyridinium ion. Organic bases in this course will all have nitrogen atoms with lone pairs. Here are 3 more examples of organic acids. I've written the name of the acid, its structure, and then given its chemical formula. Here are 3 examples of organic bases. I've drawn the structure, given the name, and provided the chemical formula.